In this video, we're going to talk about the pH scale. This is another way to communicate acid or base strength. So pH is equal to the negative log of hydronium ion concentration. You might also see this written as proton concentration as well instead. So for something that, say, like neutral water, so we know from our KW expression that the concentration of hydronium ion should be 1 times 10 to the negative 7. Well, if I take the negative log of this value and plug it into my calculator, that's going to equal 7. And so that's where we get the neutral pH standard from. Now, if you're unfamiliar with logs, I recommend brushing up a little bit through Khan Academy or another resource like that. But there's a log button on your calculator. So the way I would enter this into my calculator is I would put, depending on the type, if it's my basic scientific calculator, I would first input my 1 times 10 to the negative 7 value. Then I would hit my log button, and then I would multiply it by negative 1. Rather than making, it's important that the negative is not applied here at the concentration, but rather at the log of the concentration. And this allows us to take a very wide range of numbers that are going to go from 10 to the negative 30th to 10 to the 30th. That's an exaggeration. And put it on a logarithmic scale. That allows us to measure pH as typically 0 to 14. And it can be higher than 14 and lower than 0. But most of our values are going to fall in this range when we apply a log to the concentration. And so that's where our pH scale comes from. When we have an acidic solution, we have more hydronium ions than 1 times 10 to the negative 7. In this case, our pH will decrease. It'll be less than 7. So the acidic portion of our pH scale is going to be 0 to 7. Now, if it's a basic solution, that H3O plus, that hydronium ion concentration will be smaller because we'll have hydroxide ions around. So it'll be less than 10 to the negative 7. And if we plug that in, those values in and take the log of them to our pH equation, we'll end up with a pH that's larger than 7. So basic complexes form out in the 7 to 14 pH range. But make sure you practice with your calculator using the log button, and I'm happy to help you figure it out if it's a little bit tricky. Each calculator is a little bit different. So let's think about our body and the pH of our body. We aren't neutral. In fact, our blood is slightly basic. It's slightly larger than 7, so it's a little bit basic. Our stomach, though, that digests our food and breaks it down using acid, has a very, very, very low pH. So it's very acidic in our stomach. Our large intestine is an acidic environment as well, ranging in a pH of 5 to 7. And our urine can be anything that's from acidic at 4.6 all the way up to slightly basic at 8. Now, compared to our large intestine, which is an acidic environment, our small intestine is basic. It has a high pH of 8.5. Our pancreas is the same. It's also basic. And on the opposite side, our saliva is acidic to help start breaking down our food. So our body utilizes pH to help different types of nutrients absorb or to help break things down. And so we kind of have a wide variety of pHs within our own body.